Today's lesson is on probability. However, we're focusing on BJC questions. Also, today's lesson was created by Mrs. C. Dean. Objectives. Students will be able to interpret probability questions, calculate probability, and justify your answers. As a reminder, we are continuing on probability and we're focusing on BJC question. Our first question. Use the words in the box to answer the questions below. The words in the box are unlike, certain, like, impossible. The spinner has three types of fruits. There are bananas, apples, and an orange. The spinner is spun. What is the probability that the spinner landed on A, a banana, B, an apple, and C, a pear? Are you ready to reveal the answers? Are you ready to see the answers? So for question A, what is the probability that the spinner landed on a banana? The answer is unlikely. Can someone explain to me why it is unlikely? Okay, Cox and Elizabeth. So I see a lot of you are saying that there are 7 fruits on the spinner. However, there are actually 8 fruits. So we start at this banana here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 fruits on the spinner, and 2 of those fruits are bananas. Therefore, the probability basically would be 2 over 8, and that reduced is 1 over 4. Reduced to its lowest terms is a quarter. A quarter as a decimal is 0.25. And on our probability scale, 0.25 is unlikely. So what about an apple? Can someone explain why is it likely? Why is the probability likely that the spinner will land on an apple? Okay, let me repeat banana one more time. There are 8 fruits in total on the spinner. There are 2 bananas. 2 eighths reduced to its lowest terms is a quarter. 1 quarter as a fraction is 0.25. 0.25 on our probability scale is unlikely. And yes, Adam, because the probability is 0.62. Okay, a lot of you said that the probability that the spinner will land on an apple is 5/8. 5/8 as a decimal is 0.625. 0.625 on our probability scale is likely. So how about C, a pear? Why is it impossible that the spinner would land on a pear? Tamari said there's no pear on the wheel. Okay, it's impossible that the spinner would land on a pear because there aren't any pears on the wheel. There's only apples, an orange, and bananas. So do we understand unlikely, certain, likely, and impossible now? For those who are wondering where am I getting or where am I quoting the probability scale from, this is it right here from our previous lesson. This is the probability scale right here. So 0.25, if we look, 0.25 is right here. So it says that it's unlikely that the spinner would land on a banana. And 0.625 is in the middle of 0.5 and 0.75. That's why it is likely. And there aren't any pairs on the spinner, so it's impossible that the spinner would land on a pair. Okay, our next question. The diagram shows a spinner. The spinner is spun. What is the probability of the pointer landing on a circle? Question A, a circle. Question B, a rectangle. And question C, a triangle. This time we want the probability. We're not using the words unlikely, likely, impossible, even chance, or certain. We're not using those words. We are calculating the probability. Remember, we're calculating the probability, therefore, we are leaving our answers as fractions. We are not stating unlikely, impossible, likely, or even chance. So for a circle, before we see the answer, how many shapes are in the spinner? Good job, Elizabeth and Irvin and Jada, Ava. There are 4 shapes in the spinner. Now, who can tell me how many circles are in the spinner? Good job, Kelsey and Geneva and Jariah. Okay, there's 1 circle. So our probability of the pointer landing on a circle would be 1/4, a quarter. Brittany said it's a quarter. Good job. Good job, Dante and Amari and Nathan. So our answer is a quarter. Now, how many rectangles are in the spinner? Good. Jason Nick said there are no rectangles, there are none. So the probability of the pointer landing on a rectangle, Jadira said 0, good. So it's 0 out of 4. Awesome. So let's move on to a triangle. Our question C. What is the probability of the pointer landing on a triangle? How many triangles are there? Good job, Serena. There are 2 triangles. Good job, Natalia. Good job, Javon. Good. So I know that there are 2 triangles and we have 4 shapes in our spinner. If there are 2 triangles and 4 shapes in our spinner, the probability of the pointer landing on a triangle is 2/4. Good job, Nathan. Nathan said 2/4 reduced to its lowest terms as a half. Good job, Chara. Okay, are we comfortable now? Are we ready to move on? Okay. A card is selected from the cards shown above. What is the probability that it is a vowel either A or E? Remember, our cards above spell the word parallel. So what is the probability that it is a vowel? A or E? Question B, one of the first 3 letters of the alphabet. Question C, a P or a L. How many vowels are in the word parallel? How many vowels are in the word parallel? The vowel is either A or an E. Good. Therefore, our answer is 3/8. There are 2 A's and 1 E. So the answer is 3/8. Question B. What is the probability that it is one of the first 3 letters of the alphabet? We got 8 because there are 8 letters in the word parallel. Okay, and remember, if your fraction can be reduced, reduce it. Good job to Mari and Janaya. Good job, Destiny. And Janae. So question B answer is a quarter, because there are 2 A's in the word parallel, and there are 8 letters. Therefore, 2/8 reduced to its lowest terms is a quarter. The answer for question B is a quarter. Now, question C. What is the probability that it is a P or a L? Now, remember what the rule for or is. There is a rule for or. Okay. So the answer is a half, and I'm going to explain why it's a half, because the probability of that it is the letter P, that it is a P, is 1/8. The probability that it's a L, there are 3 L's in the word parallel. Therefore, that's 3/8. 3/8. When we add our numerators, because our denominators are alike, 1 plus 3 equals 4. The answer is 4/8. When we reduce 4/8, using our highest common factor, 4, by dividing by 4, the answer is a half, 1/2. While I'm reading the instructions, please do not respond to the answer. Give me a chance to explain the question before you answer the question in the chat, please. Thank you very much. Remember, allow me to read the question and explain before you answer the questions in the chat. Mark has the 4 number cards below. 1 card is chosen at random. What is the probability that the card has a square number written on it? The cards below are 10, 16, 14, 12, and 18. Before I reveal the answer, can someone tell me the definition of a square number? So a square number is the product of a number multiplied by itself. Brittany gave me an example. She said 5 times 5 equals 25. So she's telling me, Miss Francis, an example of a square number is 25 because I multiplied 5 by itself and the product is 25. Elizabeth, at least Jenny May also gave me an example. She said 1, 4, and 9 are also square numbers. Remember, a square number does not mean you're multiplying the number by 2. You are multiplying the number by itself. Okay, let's reveal the answer. The answer is 1/5. The square number here is 16. 4 times 4. 4 times 4 is equals 16. The product of 4 and 4 is 16. 10 is 2 times 5. 14 is 2 times 7. 14 is 2 times 7. 12 is 2 times 6. And 18 is 2 times 9. Remember, just because these numbers, just because 10, 14, 12, and 18 can be multiplied by 2 does not make them a square number. Okay, a fruit basket contains 1 pear, 2 cherries, and 3 mangoes. 1 fruit is chosen at random. What is the probability that it is a pear? Question A, a pear. Question B, a mango. Question C, a fruit. Okay, let's reveal our answers. The probability that it is a pear is 1 out of 6. There are 6 fruits in the fruit basket, and there are 6 fruits in the fruit basket, and there is 1 pear. Question B, a mango. How many mangoes are in the fruit basket? Okay, there are 3 mangoes in the fruit basket. Therefore, 3/6, the probability that it is a mango is 3/6. When we reduce 3/6 to its lowest terms, our fraction is a half because we divide it by the highest common factor, which is 3. And what is the probability that it is a fruit? How many fruits are in the basket? Good job, Janae. Ava, there are actually 6 fruits in the basket. So our answer is 1. 6/6 equals 1 whole. A bag contains 4 marbles, 4 red marbles, 2 blue marbles, and 1 black marble. 1 marble is chosen at random. What is the probability that the marble is A, red, B, black or red, C, yellow, and D, blue or black? Okay, I'll read the question again. A bag contains 4 red marbles, 2 blue marbles, and 1 black marble. 1 marble is chosen at random. What is the probability that the marble is red, black or red, yellow, blue or black? Before we can answer our questions, how many marbles are in the bag? Good. 4 plus 2 is 6. 6 plus 1 is 7. There are 7 marbles in the bag. So what is the probability that the marble is red? Good. For all those who said 4/7, good job. Now remember question B says black or red. So we have to apply the addition rule for question B. Yes, Shakira, it was 4/7. We have to apply the addition rule for question B. So we need to find out what is the probability of the marble being black, or what is the probability of the marble being red. Then we add the numerators because our denominator is the same. Okay. When we add 1 plus 4, the sum is 5. There are 7 marbles in the container. Therefore, our answer for B is 5/7. Thumbs up for all the students who said that the answer is 5/7. Now, what about question C? Yellow marble. What is the probability that it is a yellow marble? Good job, Dante. Dante said it's 0/7. Good job, Aiden and Morgan. Good job, Adam. Yes, Elizabeth said there are no yellow marbles in the bag. Therefore, it's 0. Yes, Trinique, it is 0/7. Yes, Alice, 0. No yellow marbles. Our answer is 0/7. Good. Now, question D. Blue or black? Remember, when we see the word or, we must apply the addition rule. Okay. Our answer is 3/7. There are 2 blue marbles and 1 black marble. 2 plus 1 equals 3. Our denominator is 7 because there are 7 marbles in the bag. Good job to all of those. Thumbs up to all of the students who said the answer is 3/7.
Hi there, guys. Glad to see that you could join me again for another magnificent and marvelous math lesson with Miss Antonia Bain. I wonder what we'll be talking about today. Well, yes, that's the melodious sounds of the Bahamian Junkanoo music. But today, we have some serious Junkanoo problems. Let's get ready to multiply decimal numbers in word problems. Let's take a look at our lesson objectives. By the end of this lesson, students will be able to multiply decimals with numbers up to the thousands place and solve word problems multiplying decimals. Before we begin, let's do a quick review. What is 7 and 52 hundredths multiplied by 1 and 7/10? First thing we must do is set up our problem. Now, let's begin to multiply. When we are multiplying by decimals, we must treat it as if we are multiplying regular whole numbers. That's the first step. So let's multiply as if we were multiplying whole numbers. 7 times 2 is 14. Regroup. 7 times 5 is 35. Plus 1 gives us 36. We regroup. 7 times 7 is 49. Plus 3 gives us 52. Now we place a 0 as our placeholder and we begin multiplying by the next digit. 1 times 2 is 2. 1 times 5 is 5. 1 times 7 is 7. Now it's time to add our partial products. 4 plus 0 is 4. 6 plus 2 is 8. 2 plus 5 is 7. And 5 plus 7 is 12. We're not done yet. We need to put in our decimal point. Who remembers how many places should our decimal point be? Yes, it should be 3 places. There are 2 digits behind the decimal point in the first number and 1 digit behind the decimal point in the second number. That's 3 decimal places. So our decimal point should go here. That gives us our final answer as 12 and 784 thousandths. Now, let's look at some multiplication word problems. Before we can do that, we need to look at those multiplication keywords. These are the words that signify multiplication. Times, double, twice, equal groups, per, each, and all together. All of these and many more tell us that we have to multiply when we see them. Now, let's look at our first problem. To help us solve word problems, we must use the UPSC method. Understand, plan, solve, and check. So let's begin by understanding the problem. When we understand the problem, we read the problem. We circle what we know and underline the question. Let's begin by reading the problem. The Valley Boys rushed 3 laps at a distance of 3 and 25 hundredths miles per lap. How far did they have to rush all together? When we understand, we have to circle what we know. We know that they rushed 3 laps and each lap was 3 and 25 hundredths miles. Now that we know that, we need to underline our question. What do they want us to do? What do they want us to figure out? They want us to figure out how far did they have to rush all together. Beautiful. Now that we understand, the next step says that we must plan. When we plan, we're looking for our keywords. We're looking for those strategies. We're trying to figure out what should we do. By planning, when we look at this problem, there is a word there that tells us or signifies that we have to multiply. That word is per. That's correct. Per means to multiply. Now that we've planned, it's time to, that's right, solve. When we solve, we need to set up our problem. Now we can begin to multiply. Remember, we multiply decimals as if we're multiplying whole numbers. Let's multiply now. 3 times 5 is 15. Regroup. 3 times 2 is 6 plus 1 is 7. 3 times 3 is 9. We cannot forget our decimal point. In our number, there are 2 digits behind the decimal point. So in our answer, there has to be 2 digits behind the decimal point. Now that we've solved, the last step is always for us to check our answers. And when we check a multiplication problem, we use division. So let's set it up. Let's divide now 3 by 9 75/100ths, and we should get 3 25/100ths. If we get that, then we know our answer is correct. Let's begin to divide. Awesome! We were correct! They rushed 9 75/100ths miles all together. Beautiful! Let's try one more problem. Again, we're going to use the UPSC method. So let's start by understanding the problem. When we understand, we read the problem, circle what we know, and underline the question. Let's read the problem. Tavon's costume weighed 125 pounds. Sean's costume was 2 5/10 times heavier than Tavon's. How heavy was Sean's costume? Now that we've read the problem, in understanding, we also have to circle what we know. We know that Tavon's costume weighed 125 pounds, and we also know that Sean's costume weighed 2 5/10 times heavier than Tavon's. Now, the last thing we have to do in understanding is underline the question. What do they want us to figure out? They want us to figure out how heavy was Sean's costume. Interesting. Now that we understand, we need to plan. That's correct. Let's figure out the strategy that we're going to use to solve this problem. When we plan, we look for keywords that can help us as well. The keyword in this problem is the word times. That tells us that we have to multiply. So now, let's solve. In solving, we need to set up our problem. So let's set it up, guys. Remember, when we multiply by a decimal, we're multiplying as if we are doing a regular whole number. 5 times 5 is 25. We regroup. 5 times 2 is 10 plus 2 is 12. Regroup. 5 times 1 is 5 plus 1 is 6. We put down our 0 as a placeholder and begin multiplying by the next number. 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. And 2 times 1 is equal to 2. Now we need to add. 5 plus 0, 5. 2 plus 0, 2. 6 plus 5, 11. 2 plus 1, 3. Once we are finished multiplying, now we are to place the decimal point where it belongs. Here, there is only one digit behind the decimal point. So in our answer, there should only be one digit behind the decimal point. So our decimal point goes right there. That's correct. And our answer is 312 5/10. Now, before we are done, we need to, that's right, check our answer. And to check multiplication, we do the inverse operation, which is division. Now, I know that looks scary, but we should know that when we divide by decimals, the easiest thing is to turn that divisor into a whole number. And we can turn 2 and 5/10 into a whole number by moving that decimal point one digit to the right. We must remember though, what we do to the divisor, we must also do to the dividend. And so, we need to move that decimal point in the dividend 312 and 5/10 one space to the right. And when we do that, our number changes to 25 and 3,125. Now we can divide. Guys, we were correct! You see, it gave us 125 as our quotient. That means that our answer of 312 and 5/10 was correct. Try this one now on your own. I'll read it for you. The Saxons scored an overall score of 85 and 32/100. They received this exact score 5 years in a row. What is the total of all scores received? Remember to use the UPSC method. Understand, plan, solve, and check. Pause the video. Solve this problem. Once you are finished, press play and I'll reveal the answer. Alright guys, let's check our answer. Let's understand by reading, circling, and underlining. Let's quickly reread this problem. The Saxons scored an overall score of 85 and 32/100. They received this exact score 5 years in a row. What is the total of all scores received? Look at the problem carefully. Circle what we know. If you circled 85 and 32/100 and 5, you are correct. Those are the important information. Now, let's underline the question. The question here is what is the total of all scores received? Now, let's plan. What word in there gives us an idea of what it is that we should do? That's correct, the word total. Total means that we need to multiply. It's one of those words that can be multiplication or addition. But in this case, we're going to multiply. Let's solve now. Set up our problem and now let's multiply. Don't forget, our decimal point must match the decimal points provided in the numbers given to us. In this case, we only have 2 digits behind our decimal point. So in our answer, there should only be 2 digits behind our decimal point. Before we end, we need to check. If we were to divide 426 and 60/100 by 5, we should get 85 and 32/100. If we got that, then our initial answer was correct. You did an awesome job today, guys. Give yourselves a round of applause. Let's do a quick recap. There are numerous keywords that indicate that we must multiply. Some words are per, each, and groups. When we have word problems, we know we can use the UPSC method. Understand, plan, solve, and check. Awesome job, guys. Thank you for watching. This lesson was created by Miss Antonia Bain. Hello everyone, I'm so excited to see you. Welcome to another 6th grade math drill with Miss Antonia Bain. Let's get started. Our topic for this week's drill is decimal place value. Can you remember those decimal places? Let's see. Take a look at this number. What's that? If you said a decimal point, you are correct. Now, let's look at the digits to the left of the decimal point. The digit 2 is in that's correct, ones place or units, and the digit 1 is in the tens place. And of course, we know if we continue on in that direction, we would get hundreds, thousands, 10,000s, and the list goes on. Now let's look at the digits to the right of our decimal point. Those digits are less than a whole number. The 3 is in our tenths place. The 5 is in our hundredths place, and the 6 is in our thousands place. Can you remember that? Remember, the digits to the left represent our whole numbers, and the digits to the right represent those numbers that are less than 1, our decimal parts. Use the information you've just reviewed to help you identify the place of these digits. Let's look. We have the number 3 and 58 hundredths. Which digit is in the units place? Think hard. Remember, units also means ones place. If you said 3, you are correct. Good job, guys. Let's look at this number. Can you say that? Yes, that's 244 and 1/10. Which digit is in the hundreds place? If you said 2, you are correct again. Good job, guys. Let's look at this number. This looks hard, but I know we can call that. That number is 9,729 and 85 hundredths. Which digit is in the tenths place? If you said 8, you are correct. Awesome job. Let's look at another one. Can you say that? Yes, it's 73 and 712 thousandths. Which digit is in the hundredths place? If you said 1, you are correct. This is the last one, guys. Say that number. Yes, that's 23 hundredths. Which digit is in the hundredths place? If you said 3, you are once again absolutely correct. Let's do another quick review. Remember, this symbol represents our decimal point. The numbers to the left represent our whole numbers, and they begin with the ones or units place, tens place, hundreds place, and the list goes on. The numbers to our right represent our decimal numbers, those that are less than 1. And the places are the tenths place, the hundredths place, and the thousands place. This lesson was created by Miss Antonia Bain.